Hello everyone, this video is from Nex Robotics. For introduction, we have LPC2148 microcontroller development board. It is a USB powered board. Let me make the power connection, a USB which is connected to my PC and a switch for power on and off. The board has on board 50 pin expansion header slot which is connected to all ports of microcontroller with 3.3 volt power supply to the external devices, and for its operation we need to remove the respective peripheral jumper connections from the board. Microcontroller adapter board with 12 MHz crystal, lithium cell 3.3 volt battery for power backup to RTC. For serial communication we have two UART, UART 0 and UART 1, 2x16 character alphanumeric LCD for display, a variable port to control the contrast. Let me remove the LCD. 4 user switches, 2 analog potentiometer connected to ADC of microcontroller, ULN2003 driver, and its pin connection to drive 7 different loads up to 500 mA current. Adapter board for Zigbee, Wi-Fi and Bluetooth wireless communication connected to UART 1 of microcontroller through the jumper connections. A buzzer for interfacing. 4 user LEDs. SDMMC card socket for external removable storage device accessible in SPI mode. TSOP 1738IR receiver. By removing the jumper connection, we can connect to any port of microcontroller through one-to-one connector for the operation. L293D dual motor driver IC and pin connection to connect to DC motor or a single bipolar stepper motor, and jumper connections for fixed and the variable velocity. Type B USB connector for power supply and also for communication. 2x5 JTAG port for on-chip debugging, microcontroller reset switch and a boot switch. All the peripherals onto the board are connected to microcontroller through the bridge connections which is aligned in sequence for the convenience to remove the jumper connections for external device interfacing. One of the important and highlighted feature of the board is the microcontroller adapter board is removable and replaceable. These are the technical specifications of the board, and now I'll show you how do we create a hex file and load it onto the board. For creating an hex file will require an IDE, that is for debugging and the compilation of our code. For that we are having Keel Micro version 4 and a Flash Magic to load the hex file onto a board. So starting with the Keel Micro version 4, this is how the window looks like when it is open. So now we'll create a new project. For that we'll go on project, new microvision project, specify a directory to it with a folder. As I've given name to a folder, and in that I'll create a file with the same name. Once you have done with it, now we'll select the device, and that will go in an XP founded by Philips, and select the device as LPC2148. Once it is done, we'll click on OK and say yes to it, as it internally adds the startup.s file. As we can see, this is startup.x file. Now we'll go on file, click on new, we'll create a new file. As we can see, text 1 has been created. Now we'll save this file into the folder and give it a name. As we can see, now the file name as I have given right now, the main.c has been created. Now we'll add this file to our source group 1. We'll right click and add and go on add files to source group 1. Click on main, add. As we can see, I've click on add, the main.c file has been added. So now once it is done, now we'll go on project, and that will go on manage components, and that will go in folder extensions, internal changes to our compiler, and that make sure that tool based folder is having the proper path. Default file extensions are all okay. If it is done, we'll click on OK. Once it is done, then we are almost ready to write our first code, but we'll also make changes to target 1 depending on the board that you are using. In that target, the crystal will select as 12 MHz, and the output will click on create hex file. In the linker, we'll click on use memory layout for target dialogs. Once it is all done, we'll now click on OK. Now we are ready to write our very first code. As I've already written the code, so I'll not write it again. So I'll just copy and paste and save it. Now I'll click on rebuild all targets. As we can see, a message in the box showing creating hex file with 0 errors. Once it is done, we'll go on project and that build target. As we can see again in the dialog box, there's a 0 error with 0 warning. That means our code has been successfully compiled, and if we go back to our base folder, in that we can see a hex file is being created. So this is how we have created a hex file, and now I'll show you how do we. Now to load the hex file onto the board, we need to make the connections. For the connections, we are having a serial cable. This is the serial cable that we are going to use, and a USB to RS232 converter, that is USB to serial converter. Now I'll make the connections. I'll connect a USB to it, and I'll connect the serial connection. And to the UART0 of our board. So this is how the connections has to be made for loading the hex file. Now once the connection are done, now I'll show you how do we load the hex file onto a board. To load the hex file, we'll use FlashMagic. FlashMagic, once it is open, now we'll select device as LPC2148, click on OK. The COM port, yes, for the COM port you need to check into your computer's device manager, which, like in which the COM port that it has allocated to you. So for that, we'll check into the properties. We'll go into the device manager. In that, we'll click on ports. In that you can see USB serial port as COM port 6. So FlashMagic, I'll select the COM port as COM 6. Set the desired baud rate to 9600. Interface is non ISP. An oscillator 12 MHz crystal. Once it is done, we'll click on verify after programming, and we'll go on browse to select the hex file. That we can see LED chasing.hex file. Now once it is done, we'll read the device signature, but for that we need to enter into the bootloader mode first. So for the bootloading mode, it is one of the important and the necessary steps for any of the operation to be done on the microcontroller. So I'll show you how do we go into the bootloader mode. For that, we'll press the boot switch, simultaneously press the reset switch, release the reset switch, and then release the boot switch. This is how we go into a bootloading mode. So now once we have entered in the bootloader mode, now we'll click on ISP and read device signature. We can see the device ID and the bootloader version has been read successfully. Now once it has been done, now we'll click on start to load our hex file that we have created onto a board. So when I have clicked on start, we can see a programming, and also you can see on the converter the transmit and the receive LED is blinking. That means the code is being now successfully loaded onto the board, and you can see on the FlashMagic also once it is loaded, a finished message has been showed to us. Now once the hex file has been loaded, now I'll just press the reset switch. As we can see, our LED chasing code is now working fine. So this is how we can use any of the peripherals on the board and can use it. For more details on technical specification and features on the board, please visit our website, Nex Robotics. Thank you for watching the video.